In this video, we'll be looking at the introduction to logarithm. And if you have not subscribed to this channel, kindly subscribe so that you'll be the first person to be notified when a new video is being uploaded. Now let's get started. The overview of logarithm. We know that 2 exponent 3 is the same thing as 2 times 2 times 2. That's going to give us 8. And so we can deduce that 2 exponent 3 is equal to 8. That is fine. Now, what if we have 256? 256 implies that 4 must be raised to a particular exponent for us to get 256. So if you know the particular exponent that is being raised to in terms of 4, then we are going to get 256. Now, how do we get it? So this is where logarithm comes in. So we can apply logarithm in order to get 256. Now, in other cases, in indices, we said if we have 2 exponent x, which is equal to 2 exponent 2, and we are saying once the bases are the same, then we can equate the exponent, and thus we have x is equal to 2. Now, what if we have 2 exponent x, which is equal to 3? Now, at this point, we can see that the bases are not the same, and therefore we cannot even equate the exponent. So, in cases like this, how then do we find x? So, this is where logarithm also comes in. And so these are some of the usefulness of logarithm. Having known this, then let's move to the representation of logarithm, and further we'll look at the meaning of logarithm and how we can apply it. Now, the representation and reading of logarithm. The short form of logarithm is what we call log. So logarithm has its short form as log. And if you see anything written like this, then it basically refers to the short form of logarithm. And hence, if we have logarithm a and b here, it implies that the a is what we call the argument, and the b is what we call base. Henceforth, if we have something like logarithm m, n, it means this logarithm has an argument m and a base n. Now let's go to how we can read this logarithm. Now, if you consider logarithm of the argument a, base b, how then do we read it? Now you can read it as logarithm of a, logarithm of a to the base b, and that's how you can read this. Now when we come to log mn, then we can say logarithm of m to the base n. That is how we read logarithm. Now, to make everything short and simple, let's move to the meaning of logarithm. Now, meaning of logarithm. Logarithm is the exponent to which a given base must be raised to produce a specific number or the argument. Let's take it again. Logarithm is the exponent underlined to which a given base, also underlined, must be raised to produce a specific number or the argument, which implies that if we have logarithm of 8 to the base 2, it implies that what exponent must 2 have so that we are going to get an answer of 3. So if we have 2, what exponent must 2 have in order to get an answer of 8? So we can think of 3, because 2 times 2 times 2 is going to give us 8. And so the answer to this logarithm of 8 to the base 2 is 3. Better still, we can consider logarithm of 9 to the base 3. How do we get the answer? We ask ourselves, what exponent must the base 3 have so that we get an answer of 9? Which implies that 3 must be raised to the power 2 for us to get 9. And hence, we can say our answer here is 2. And that is the meaning of logarithm. So this is to tell us that logarithm is another way of expressing indices. That's the basic idea. Having known this, now let's note one or two things on logarithm. The first note says that when the base of a logarithm is not written, it means it is in base 10, which means that in logarithm you can have different bases. You can have base 2, base 3, base 4, base 5, base 8, base 10, and the rest. But we don't have base 1. So in logarithm, if we have a logarithm and the base is not written, then it means it's in base 10. Now we can think of logarithm of 2. Now this logarithm of 2 means that it's in the base 10. So it implies it is log 2 base 10. But in case we see anything log 2 like this, it implies it has the base of 10. Now if you have logarithm of x, now this logarithm of x implies that it has the base 10, which is equal to logarithm of x to the base 10. Now this is what we call the common logarithm. Common logarithm. That is when the base is not indicated, but we know to be the base 10. We can think of the natural logarithm, and the natural logarithm happens to have a base e. That's the Euler. So we can have logarithm of x to the base e. It implies that it is this log to the base e is what we call ln. And if log e is ln, then what is left? X is left. So you have ln x. So anything of this form is what we call the natural logarithm. Natural logarithm. But in any case, if the base of a logarithm is not written or shown, then it implies it has a base 10. That's what we call the common logarithm. Now the second note, the base of logarithms can be written in any positive number except 1, and the logarithm of a negative number does not exist. Simply put, if you have logarithm of b to the base a, we are saying that the base a should not be equal to 1. It can be any positive number apart from 1, which means we are not even considering negative numbers for the base of a logarithm. It implies the base of a logarithm should be positive only, and if you are thinking about positive numbers, it should not include 1, and then negative numbers does not exist in logarithm. And the second one, the logarithm of negative number does not exist. That's what we said earlier. So that is that. Now let's move to the next note. So the third one, it says that any statement in index form has its equivalent form. For example, 8 is equal to 2 exponent 3 is the index form. And so 8 equivalent logarithm form is what we have as logarithm of 8 to the base 2, which is equal to 3. So it means that provided we can write something in index form, we can also write it in logarithm form. So with this, then let's look how we can change from index form to logarithm form, and then the vice versa. That is from logarithm form to index form. Now, changing from exponential form or index form to logarithm form. Now, this is how it works. Let's assume we have the exponential form or index form as a, which is equal to b exponent c. Now, if you want to change this index form to logarithm form, then we have to apply logarithm, which means we can apply logarithm here. Now, we can see that the logarithm can be applied to a. So, we can write our a here. Now, when we look at this index form or exponential form, what is the base here? The base here is what we see as b. So, when we come to the logarithm part, it is also going to maintain its position as a base at the logarithm side. So, we have b here. That is, the b is still the base in the logarithm side. Now, what is left is c, and we can see that c is at the back of the equal to sign is going to maintain its position. So we have here, which means that a is equal to b exponent c can be expressed in logarithm as logarithm of a to the base b, which is equal to c. Now, if you consider m to be equal to n exponent p, this is an index or exponential form. And so changing it to logarithm form, then we have to apply logarithm. We are going to have logarithm of m, and then when we look at this index or exponential form, the only base we have here is n. And when we come to logarithm form, it's going to take the same position as the base, which means we have n here as the base at the logarithm part. Now what is left is p, and so you are going to equate to p. And that's how you can change from index form or exponential form to logarithm form. Having known this, let's try one or two practical examples. So these are the examples, and it says that express the following in logarithm notation. So these are exponential forms. Like we said earlier, you have 16 to be equal to 2 exponent 4. If you want to change this to logarithm form, then you have to apply logarithm. So you apply the logarithm to the 16, and in this index or exponential form, the only base here is 2. And when we come to logarithm part, it's going to bear the same position as the base, which means we have 2 here. Now the only number left here is 4, and then it can be found at the back of the equal to sign, so it maintains its position at the same place. So that is how you can express 16, which is equal to 2 exponent 4, in logarithm form as this. Now let's try the next example. We have 125 to be equal to 5 exponent 3. To change this to logarithm, then there should be logarithm. Logarithm of 125. Now in the index or exponential form, the base here is 5, and it's going to assume the same position as the base in the logarithm part. So we have the base here, and the only number left is 3, so we bring out 3. Having known that, we go to the next example. That's the third one. So in the next one, we have 3 squared to be equal to 9. Now when we compare 3 squared to be equal to 9 and 16, which is equal to 2 exponent 4, their position is different. So in order not to confuse ourselves, then we can write this as 9, which is equal to 3 exponent 2, which is basically the same. Now with this, we just have to apply logarithm of 9 here. And when we look at new format of the index or exponential form, the base here is 3, so we bring our base here, and the only number left here is 2, and then we write out 2. The next question, we have 2 exponent 3 to be equal to 3. So likewise, like we said, we can write it as 3 to be equal to 2 exponent 3, which means we can apply logarithm, and we have logarithm of 3, and the base is 2, which is equal to the 3 here, and we have our 3 as such. And that's how you can change from exponential index form to logarithm form. Now our next trial is going to be where we are going to change from logarithm form to exponential form or index form. Now we have here changing from logarithm form to exponential form, which means we have logarithm of a to the base b, which is equal to c, and we want to change this logarithm form to exponential form. Now in changing it, this is what you must have in mind, or as a stepping stone for us to get the concept. We can try to chip in the idea of cross multiplication, which means this a is kind of coming to take or multiply a number here. We know C is being divided by 1, so it means we can bring the idea that a is going to multiply 1, and then the b here is going to multiply c. But this instance, b is not going to multiply c, but b is going to be raised to the power c, or the exponent c. So we can write our answer as, now a takes the number we have here, so we assume that is 1. So if a multiplies 1, then we are going to get a, which is equal to b is going to take c. but b taking c is not going to be in the form of multiplication, but b is going to raise to the power c. That is b exponent c. And that is how you can change from logarithm form to exponential form. We can still think of the logarithm form if you have logarithm of m to the base n, which is equal to p. With the same ideology, we can see m is coming to take a number like 1 here, so m multiplies the number 1 here, and then n is going to multiply p, but in this case n is not going to multiply p like we are saying, but that's the scenario. But n is going to raise to the power p, and so we can write our answer as m, which is equal to n exponent p. And this is how we can change from logarithm form to exponential form. So having known this, let's try 1 or 2 examples. So it says that write the following in index notation. We have our first example as logarithm of 8 to the base 2, which is equal to 3. So in simple put, that means the 8 is going to come here, and then our 2 is going to take 3. So to write our solution, then we can consider 8, which is equal to, now 2 takes 3, we have 2 exponent 3. And this is how we can write in index form when we have the logarithm form. The next example, we can think of logarithm of 5 to the base 4, which is equal to x. So this implies that the 5 is going to come here, and then the 4 is going to take x. So our final answer now becomes 5, which is equal to, now 4 takes x, so 4 is going to have the exponent of x. The next example, we have 5 to be equal to logarithm of 32 to the base 2. Now with this, it's kind of different from the first example here based on their position. So to make things easy, we can rearrange, and we have logarithm of 32 to the base 2, which is equal to 5. Having gotten this, then we can see 32 is going to come here, and then 2 is going to take 5. Thus, we can write our final answer as 32, which is equal to 2 exponent 5. Now, our next example, we are going to consider y, that is equal to logarithm of 4 to the base x. So comparing the position and arrangement, we can see it's quite different from logarithm of 5 to the base 4, which is equal to x. So with this, we can rewrite or rearrange as logarithm of 4 to the base x, which is equal to y. And hence, we can see that this 4 is going to come here, and then our x is going to take y. And henceforth, we can write our solution as 4, which is equal to x exponent y. And this is how we can change from logarithm form to exponential form. And this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. BakoMaths, thinking beyond infinity.